So let's look at this particular item, missing value. The traditional way of dealing with missing value is if a record has a missing value, then you just remove the record, don't use it. Because it has a missing value, and you know, in a regression analysis, if you have numerical variables and you have a missing value, you cannot compute your sum of squares. So no way that that column can be used. You just throw it out. All right? Throw that observation out. Okay, now when you do that, then what will happen is very quickly you'll realize that you're going to get most of the records thrown out. Okay? Suppose if you have a data set with 30 variables, okay, and then 5% of the values are missing. Only 5% of the values are missing. Okay? So you have 30 variables, you have a bunch of data, 5% are missing throughout. Right? Now, what is the probability that a given row will have at least one value missing? Because one value is missing, that row will get thrown out. Okay, so each column, okay, so there's a 5% chance that that one particular value will be missing because there is 5% missing in the whole data set. So 95% will not be missing. So you have to have you will have 95% probability for the first column that it will not be missing, 95% probability the next column it will not be missing, okay, and so on. Okay, so if you go 95% times 95% for the second column times 95% for the third column, so on to 30 columns, then you end up with the probability of all of them not missing is 21.5%. So close to 80% of the observations you'll throw out. Okay. So this is not a good solution to throw observations out, okay, because of missing value. So you have to come up with something, some other solution for this. So again, so here are the ways in which you can deal with missing values. Okay. First solution is no good. Okay. Omitting, it's a problem, right? And the second solution is imputing. That is, you come up with some value. If it is a missing value, then you come up with some value that you can put in there. Of course, it has to be reasonable. You can't just simply make things up. So there are several methods available out there for this imputation. If you look at some of them, okay, or you can drop or replace the variable. So if a given variable has too many, this is what we looked at in the advanced metadata. If a particular variable has too many missing values, just throw that variable out. Okay, maybe you can replace it with something similar. So, for example, age and experience, right? If experience has, in your analysis, maybe experience is a better variable than age, and suppose if experience has too many missing values. So your first choice has too many missing values, but your second choice experience is very similar to age, so you keep age in there if age has less of missing values. Okay. So that would be, and what we are interested here is imputation. And that's how you do missing values. Solution one is omission. Of course, that's not good. Imputation. So the possible approaches. Okay. And then drop the variable. Okay. Now let's look at imputation and the ways that you can impute. One way of imputing is compute the mean of that column. Suppose if experience is missing, you compute the average experience for that column and put that average wherever it is missing. Okay. That's a reasonable approach. But the downside of this is that it has a tendency to decrease because wherever there is missing, you're going to plug in exactly the same value. So it artificially will deflate the variance of that variable. Okay. So that is the problem with computing a single value. So it could be mean or median, and you replace that with that. Okay. The other one is to run a regression. Okay. Suppose if experience is the column that has some missing values. So make experience your y. Okay. Now don't include the target. Okay. You include all other x's, all other predictor variables as the x's for this regression. So this is just a make-believe regression that you're running just for the purpose of imputation. So the variable that you want missing values to be replaced, make that your y, and the rest of them as x, and run a regression. Now you have an equation to predict what the y will be, y being the missing value. Okay. Missing value of that given x, right? So now, whenever there is a missing value, you take the values of the other x's, plug it into that regression that you have found, compute your y hat, and use that as your imputed missing value. So in place of the missing value, you use that y hat value. Okay. So that's good for interval variable. But what about categorical variable? So if you have categorical variables, then you cannot run a regression analysis for that. So if you have categorical variables, then you can use mode, a value that occurs most often. You replace a missing value with that.
So if age was missing, I mean, if the sex was missing, and there were slightly more women than men, now there's going to be a lot more men.
Exactly, yeah. Yeah. These are, of course, this is not perfect, but we are just trying to mitigate as much as possible impossible situation. Okay. So let's look at